Hello. This is immensely strange. I am talking to my computer at the moment, but hello out there, YouTube world. Welcome to NorDev Live, first of many live sessions, hopefully, over the coming months. First up this evening, we've got Data Science in Practice. We're going to be hearing from John Fagan, talking about project managing data science projects. And all the things that come with agile delivery of data science, etc. We'll be then moving swiftly on to Danny, who will be taking us through a Jupyter notebook and showing us basically the favorite tool of many data scientists. Again, like I said, this is very strange. There's nobody to really talk to. I guess I've been watching a few of these things. I think the thing to do is to say you need to subscribe and like down the bottom. That really helps the channel. I think that's the thing to do. But I'm going to skip on quickly, as I like to do. Just a quick mention of a few ways you can get in contact. Obviously, we've got the chat. Mez is kindly in the other room, staffing up both Discord, the Zoom chat. She's on the socials and the YouTube chat. So any questions, etc. on there, we'll be fielding them along. And there's also a Q&A on Slido. So that's sli.do. Enter the code 40055, and you can pop your questions on there. And again, Mez will be fielding those across. So without further ado, hopefully I'm going to be able to push a button right now and introduce. Oh yeah, there we go. So if I tap this, I shall be introducing you to. It's totally broken. I can see it on the stream output right now, and it is not looking good. Oh no. Well, first of many technical problems I'm sure that we will be experiencing along the way. Oh no. Bear with us for one moment. Okay, what's going on here? Right, we should have Sean's microphone coming through now. Have we got... Hello. Yeah, we'll sort out the video feeds in a moment there. John, you should be coming through right now. Yeah, what I can't find is an option to add a fourth person. Blimey, here we go. Add an audio source. Sorry about this, everybody. Danny, welcome. I think we can hear you now. Yes, we can hear you. Hello. Right. Sorry about that, everybody. Okay, you're all right. I'm gonna try and sort this out while we talk. So, hey, first off, I guess introductions off to John. Hello. How are you doing? I'm going to pass over to Sean to say his dues while I try and sort out this view we've got going on YouTube. I literally can't sort it out. They don't seem to change. No, there's 4 of us. If I move. If we go try this.
Michael Davies said he could not hear me.
There we go. Right.
Hey.
I think I've fixed it.
I think you have.
I think I may have fixed it. I'm really sorry about that, everybody. Technical issues, of course. Right, I think I can just see the stream output now catching up. So, hello, everybody. Sorry about that. I think we're going to pass over to John just to do a quick introduction. Not that he needs much of an introduction to the NorDev crowd, nor does Danny, to be fair, after a NorDev conference spectacular. So, yeah, over to yourself, John. Sorry.
Hi. John, Sync Norwich, Norfolk developers, enjoying the weather at the moment, and looking forward to talking about agile data science.
Awesome. You look like you've got the sun literally beaming out behind you there. It looks
I
Oh, wow.
looks like you got a bright idea at any moment. Full of them. Hi. Okay. And over to Danny. Hi, Danny.
My name's Danny.
Oh no.
Oh no. You hear? What's going on?
Oh, just about hear you.
Oh, no.
Can you hear me now?
Ah, yes, I can hear you. We can hear you.
Yep.
Okay, should I start again?
Yep. Go for it.
Okay, my name is Danny. I'm a data scientist. I work for a startup in Birmingham. The startup is called GridEdge. And my background is in civil engineering. And I'm currently studying for a master's at the University of Huddersfield and in artificial intelligence. And that's all from me.
Thank you very much. Well, like I say, very popular talk at NorDev Conf. Had loads of good feedback on there. It was a packed out room. Yeah, it was good. So it's good to have you back with us. Right. So first up, we're going to be hearing from John, like I say, with agile data science. And we're probably going to go experience the same technical issues we did a moment ago with trying to get this live. But I'm going to pass over to John in just a moment. Oh, and you are possibly live. You are live, John. Oh, one sec. Sorry, John. Sorry. Sound. There you go. I've got your sound in there. Now you're good to go. Apologies again. You should be able to now. Oh, sorry, John. Yeah, I think we're good. I can. Yeah, there was an issue initially, but I'm not so sure. I'm just going to confirm. What's that? You can hear now? Can you hear now? Mez? What do you mean you're only getting me? How long's the delay? Okay, so can I get you to talk again, John? Sorry. Amazing.
You did have the sun on your side there briefly.
So, right. Okay, so there's a considerable delay.
Yeah, I'm getting good.
But I've just put us all back into the 4-grid mode. And I'm just going to watch now. Just going to watch now to see if it catches up, I guess. Sorry about this.
Data science.
I just saw your... Okay, we've got all 4 of us. It will do all 4 of us, but it won't do the...
Hello. Can you hear us?
This is so weird, hearing yourself back about 30 seconds later.
It is weird, yeah. It does seem to be working, and it does have all the sound, though.
Yeah, right. Okay, so let me try popping back over to the green room.
They can hear us.
What a palaver.
Yes. Can everybody hear me? How you doing? John, say something, says Mike. I'm not going to do a data science dance, Selena. Well, I could. Yeah, I need a few people. Michael says he can hear me. We're ready to go. Yeah. I can hear background noise. Might be working. Yeah. Right. Are we ready to go? Can I? Sweet. Yes. So, hello everyone. I think we're here. Someone shout if you can't hear me. It'll have to be. I'm not looking at the comments at the moment. So, thanks Alex and Sean for inviting me to come talk today on data science. Today. I'm just going to share a few of my challenges I've had over the last 5 years. As a lot of organizations have started incorporating machine learning into their solution stack. We have experienced quite a bit of pain early on. I mean, it's actually good. And a lot of companies, you might get a funding round, have a bit of money, and then go and hire some data scientists, update your marketing message, and boom, we're an AI company. We're powered by AI. So you've seen a lot of that over the last few years. And we were lucky. I mean, we literally hired PhD data scientists by the 6-pack. We hired a bunch of them, based in New York, and yeah, we're all high growth, high excitement, and they literally blinded me by science. Actually, really, I knew nothing about data science, nothing about AI, nothing about machine learning. So I did feel quite intimidated talking to a lot of these guys, all PhD students with a bit of industry experience, highly motivated, and talking using a whole bunch of terms that I wasn't familiar with. So that created, to a certain degree, because I felt intimidated by them, I wasn't really able to influence them and sort of guide them as I would have hoped. Really, before we even started hiring, we should have really questioned: do we need AI to solve the problems we have? Just a classic statement. Oh, and then if we do feel we need it, are we ready for it? And then, what is a data scientist and what can they do? I kind of joke with our data scientists in the company. I call them wizards. But data scientists come in all flavors. So, and you'll really find this when you're trying to hire data scientists, and you'll put out of all the roles you hire, when you put a job spec out for data scientists, you get all kinds of people applying for it, so it's a real challenge. You'll get I normally find you get a lot of CVs, particularly from an academic background. But, there are different types of data scientists, and some of them are a lot more clear-cut than others, particularly around the data engineering. The data analyst, in here it says business intelligence engineer. That's maybe more of a classic kind of data analytics person. Then you've got you do have this role of a data scientist, which is a bit more on the machine learning. Then you've got a more academic data scientist, less involved in production. And then you've got an applied data scientist who is really more involved in productionization and has some experience in software engineering. So, in terms going back to the question, are we ready for AI? I don't know if any of you guys have seen this this slide in the data science hierarchy of needs. And really, you need to walk before you can sprint. And we jumped in right at the top of the pyramid when we hired our team in New York, and we didn't get the results we hoped. And this is a nice hierarchy of all the things you kind of need to do before you can get to the top of that pyramid. So it's basic, collecting data, having a good pipeline in storing it in storage and keeping it up to date, and then maybe doing some transformations, basic cleaning, anomaly detection, etc. And then you can start looking at it from a statistical point of view, aggregating the data. Then you can go further up the stack in terms of using machine learning and deep learning in the end. Also, I like this other guy sort of adapted that hierarchy of needs into a sideways pyramid, and he talked about data needs in the organization and then overlaid roles in there. So that kind of gives you an idea of when you might want to hire the particular skill sets you need. And certainly I don't think you need it in the beginning. And that kind of almost aligns quite nicely with the classic product development and startup life cycle, when you're introducing a new product to market, going through the different phases. And, I do kind of question sometimes when you see new startups out there, even when they haven't released a product, they're calling themselves an AI company. And I go, well, I'm sure you haven't got any data, so I don't really think, you are an AI company. Maybe they've bootstrapped their AI by acquiring some data or some open source data, but generally, I kind of dubious of that. But this kind of gives you an idea of when you might want to hire the particular skill sets you need within the organization. But I suggest, you can start preparing before, for the machines arrive. And, Scrum and Agile is really a great way to do that, to make marginal improvements and continuous improvements to be prepared. Because if you don't do this, when you do hire that data scientist, you're not going to get the best value out of them. They're going to be spending months, it'd be a year. It'd be a year before they're really delivering any value. Each sprint just keeps ticking over. And, I advise you guys, particularly if you're in a startup, but this is also if you're deploying a new product within an organization, to start taking care of your data, thinking about, I kind of put here, data hygiene, trying to get some standardization in your data models, trying to think about, data scientists down the road and how they're going to connect data up. So having, transaction IDs within, different data objects, within data flow. And also I start thinking about building a simple data archiving mechanic. Don't worry too much about having, like a data warehouse and a structured data model, but, think about archiving data. And also, obviously, if users deleting data, your archiving has to support that. And you could do this by finding a hobbyist in your organization, someone, a tester, a software engineer, or maybe a DBA that kind of starts taking care of this, keeps an eye on, on your sort of storage and your schemas, etc. And you can just start tuning up your definition of done a little bit from a product owner's point of view to take a bit of interest in where that data goes and making small changes all the time, cleaning up the bottom of that pyramid, basically. Then also, I think, this is for everyone. Whenever I'm doing a one-on-one with a software engineer, I always kind of advise them they need to start getting familiar with machine learning, because that is the future of coding, as far as I'm concerned. But everyone can start becoming data science literate, understanding the basic components about what's supervised, unsupervised, and classification types of algorithms and models. How do you evaluate models, and all the high level terms that you may use. Lots of great podcasts out there, tons of small YouTube clips out there, really to start getting familiar with this. And then you could even do a short course. So with these two things, like just taking care of the bottom of that pyramid and also acquiring a bit of understanding of what it requires to run, to solve things through machine learning will help. A bit of a kind of elephant in the room, and it's been a huge challenge for us in bringing these two cultures together in terms of data scientists. And, if you're a software engineering organization and you're used to shipping stuff within sprints and deploying, you could say that data science and data mining comes from, more of a waterfall, process, where there's a whole, there's certain steps you have to follow. You can't do like a nice thin slice through it all and deliver an increment. So kind of a lot of people do like to maybe work in a waterfall fashion, but I do like this. It's another pyramid, and this is data value pyramid from O'Reilly. O'Reilly's put out a book, Agile Data Scientist. This is something I actually wanted to write myself 5 years ago, when I realized there was a massive hole. I searched online. I couldn't find anything for product managers on how to manage and deliver incremental value in sort of data-based, data science-based driven products. And they've got this data value pyramid here, and you can see the kind of values you can deliver throughout as you go up to the more advanced products you're delivering. And then again, if you kind of align that with the other pyramid I showed you, again, you can kind of think about what roles you're going to be looking for and when. But I do you got on the data loading, you got IT engineering there, data analysts. I do feel like, you can go quite far without getting those specific skills in the team before you need to do that. And I do recommend doing it through the agile process, incrementally improving the bottom of your pyramid, maybe up to the cleaning and aggregate, and do some basic visualizations, loads of good tools on that. You could even maybe get up to the reporting, to that kind of level before it depends on the size of your data. If it's big data, then you will need a data engineer. But that's kind of what I've learned there. We really hired a lot of data scientists. At some point we had 8, where we hadn't even really got the basics in place. And those data scientists are so passionate, they really want to deliver value. The data's not quite there, we don't have enough data, so they went down the road of generating synthetic data. And how they generate the synthetic data was absolutely amazing and worthy of a journal article. But when their models were having high precision, and recall, and it's like in the 99%. But really, when we tried it for real in the field, because the projects we're working on were taking sensor data, location sensor data off the device, and we had to predict what users going to do in the real world, it just didn't translate to working in the real world. So once you kind of, getting to the point that you feel like a data-driven solution is there, you have to work on defining the problem. And this is, when you're defining the problem, this is the hardest part, actually, to align thinking and outcomes with different parts of the organization and using the same language. And you have to spend way more time on defining the problem that you would on a classic, I say problem here, which requires basic CRUD, to solve it. So, you need to spend a lot of effort on that. And I thought this article is, was originally, you see, released in 2013, and it still works. I've used it a couple of times. I haven't used it enough, but it finds a really nice template. It has the whole workflow in there. I've just picked this one as a whole nice template describing the problem. Any of you guys there, I highly recommend to go and look at Machine Learning Mastery. It's a guy based in Melbourne. I've actually personally emailed him and he's responded, and he's putting out a lot of great content. And he's targeted at software engineers, making developers awesome at machine learning. Just going further into that kind of template here, he's like, it's just really well laid up, just an informal description there. Describe your problem as if you were to your friend, and then a formal description there has a bit of a templated example there of the task, experience, performance you're expecting. And then also what I really like here is in the assumptions area, where you kind of, because data science and machine learning and feature engineering and all that can be really overwhelming as a PO, and you don't really know what's going on and you don't really understand, there's this difference in language. And here's like just assumptions of the model. You can write them in specific, just easy to understand English. So this particular example here is a solution to predict the retweetability of a tweet you're composing. So in the model, we're going to say the specific words used in that tweet matter to the model. The specific user that retweets does not matter to the model. The number of retweets matter. Older tweets are less predictive than more recent. So in the model, so that's, it's quite simple, and you could really brainstorm those in the early stages in the workshop. And then I like you can research similar problems. So that just forces a bit of, you might on the assumptions and everything, you might think you're fully aligned. And then you talk about similar problems. Oh, this is similar to this on Netflix or anything like that. And that's where you go, no, it's not similar to that. And that creates good, I love that part of it. It creates good discussions further to align yourself with the data scientist. Then you can go into the classic motivation solutions and solutions to use. But that step 3 is another really good one. Just describe how you would solve this problem manually. And that, again, this all kind of aligns yourself. So I highly recommend looking at that site. And like when I saw this formalism and the assumptions there, I immediately go, oh, wow, that looks like BDD. Although the guy wasn't familiar, that's when I emailed him. I said, you're describing BDD. I've reformatted. And he asked me, could you write me a blog post on my site talking about that? And I said, yes, but I never got round to it. But I've just factored it here into a classic user story with some acceptance criteria in BDD format. It's still not like perfect BDD there, but you can, it's a good way to define what you're looking for, in order to reach as many people as possible. As a social influencer user, I need Twitter to predict if my tweet will get retweets before I send it, And given there is history of tweets from Elysian, is that right, Alex? And I have some retweets and some have not in the past. And when I compose a new tweet, it's going to get classified if it's going to get retweeted or not. And then you can see, as I go down here on the ands, the specific words he used in the tweet will matter So that's kind of a really good way to kind of start working with a data scientist. Then we're on to the solving your predictive challenge here. And this is where another area where you'll get blinded by the data scientists and you won't quite know how they're solving it. And what I've learned over the time is always start with the dumbest solution first. Highly recommend that, to get your baseline model. And, you could even define this as a PO, what you want the baseline model, but, the data science can do that. And we've done this at Axon, like we built an algorithm to predict when you're going to go home. You're traveling around, when you're going to predict when you're going to go home, you're going to start your journey to go home. So we actually just, the super dumbest model was whenever you're dwelling and you're starting a journey, every time we'll predict you're going to go home. And you'll be surprised by the dumbest model what your accuracy is, your precision is. You can actually get up to 60% with dumb models here. So with the retweet, you could just predict with 100% certainly each tweet's going to be retweeted. I bet you it's quite accurate already. And you could just take the average percent from the last 100 tweets that's going to get. You can just do simple model to get yourself started. Again, as a product owner, you have to take care of your test data. You've got all Alex's previous tweets there. They would be incorporated in test data, labeled of whether they got tweeted or not. We've got the history, so we're lucky. And really, as a product owner, this is kind of describing it's describing your acceptance criteria in more detail, actually, particularly when you're looking at bias and you're making selection bias or exclusion bias. Selection bias may be that we're only ingesting data from all the Twitter users' blue ticks, so kind of the elite maybe, or the verified people on Twitter. And then you kind of through that, it'll only be people who have that status will have a prediction. So everyone who doesn't have that status, they won't have a prediction of retweet, and they might might not send. They'll be composing it. The percentage of likelihood of it being retweeted is 0, so they might not actually send it. So it's kind of you're tuning it towards those people. Also, you might be saying, we don't have many people tweeting in Namibia, in Africa, and so you exclude them, and that will impact your model. But you didn't realize that you only have like 10,000 people in Namibia tweeting, so it's very slow, small margin of users, but actually they tweet a lot. So it's these things to think about. So as a product owner, you want to pay interest in your test data that you're creating. Then I would say you also want to pay interest in understanding how models are evaluated. This is super complicated, but you might just need to understand. I'm always interested in the holdout. Even when you're doing k-fold cross-validation, I'm still interested in the holdout report. So you might have all your tweets. You've got 1,000 tweets. They're all labeled up. You're going to use a certain amount of those tweets for training the model, a certain selection of validating, and then the tweets that you use for training only used for that. The tweets that you use for validating, the model hasn't seen that, and then the holdout reports similar to the validation in this holdout kind of cross validation, but there's way more sophisticated model evaluation here. It's where you just keep switching. You divide your test data up into different chunks, and you keep iterating and moving them around. Some are used for training, some are used for validation, and then you take the average of that. What I like about always having a holdout report as a PO, I kind of know where I'm at, and I only update the holdout report when we really want to expand our reach. For me, when I worked at Axon, as we grew beyond Switzerland, we started looking at Germany, Hong Kong, New York, then I'd update the holdout report. Or if the SDK changed, when we were capturing the data and we were getting a new type of data stream we'd have to update that. But it really, I use that to track the KPIs, because then you know where you are. And if it dips, you can actually go into the test data and go, we're not no longer detecting short bus trips in Singapore, so it's really easy to do that. So you really want to be into your test data, and you want to be a little bit interested in how it's evaluated and knowing about, overfitting, variance in data, and how it would impact things when you're talking to data scientists. But when you're going on to boosting, bagging, and all these things, I wouldn't worry too much about that. Also with algorithms, you've got to understand the basics. You've got the algorithm and the model. A lot of people kind of see them as the same thing, but they're not. The algorithm just ingests the data and produces the model. I think of the model as basically a deployable artifact, like code. It's just it's all derived from the data. So you'll have often all the time data scientists will try different algorithms, different parameters on those algorithms, see how they perform against the test data. And I wouldn't worry too much as a product owner to really get into this area, because it can be very scary. But you do really want to worry about the test infrastructure and deploying it, and ensure your team has this. And I know that you will be dying to get product shipment, but it's a worthwhile investment. And we adopted this kind of offline online evaluation model here, structure, where you have all your historic data, your validated results, and your offline data, and you really invest in collecting that and taking care of that data and updating it. We had test data inventory, and Sneha, she used to take care of that. And we actually got this rinse and repeat process. So whenever you've got a developer would commit, we'd run a short bunch of test data. Every night we'd run thousands of test data. So we invested a lot in this, I call it the rinse and the repeat process, to get our results and know how a model is performing. We always had a combination of, it was probably 80% heuristics and 20% machine learning models. And then, as you move that algorithm into the online environment, you're going live, you might run a blue-green deploy, just see how it's performing before it fully ships. But even in your kind of offline environment, you could bring in live data. We used to call this a mirror environment. So that's kind of, you really want to invest in this infrastructure around testing and deployment. And as a product owner, I just screenshotted this. You can, in the iterations of the model and the algorithm, you can just document them. I used to keep a spreadsheet, a little bit more information than this. What is the algorithm being used? I used to keep a spreadsheet of what this is in the early days, on what test data we used, like naming the table, what was the holdout, what's the validation, what features are being used right now. Any kind of, and then I'd ask data scientists, even though I didn't quite understand, I'd say, what have you, in this iteration, what did you change? We got a new algorithm, or did you use new training data? I just want to know, wouldn't know how, but just so I know, it's like change management. So this bit you do, want to pay interest in. So just finishing up now, as you looking at maturing your stack, you will, if you come from a software engineering organization, you won't have been exposed to the data science stack yet. And, there will be a skills mismatch, particularly as well. And we got a couple of data scientists we had that are only do a bit of Python, very comfortable with R and notebooks. And we'll get a demo of notebooks in a minute. But yeah, you will need to invest in your data science stack, everything from storage, ETL transformation, visualization, and everything. And I really think there's an opportunity to have a DevOps I've seen this popping up. And, if you're a DevOps engineer, I think it's a good area to get familiar with these tools, and a good career to be a DevOps in data science. I was going to start looking at getting one of those Axon when we're going to start building out our capability. It's actually when we're going to start building out our data lake, which is something you really need to consider as you start maturing and having, an area where all your data is archived. And the difference between data warehouse and a data lake is data warehouse is highly structured, and that can be a blocker in itself. So a data lake is, you literally just throw everything in there. You can be a bit semi-organized, but you just archive everything in there because you don't know when you're going to need it. You just throw it into S3, make sure it's secure, and then you create we called it a data science lab, which had a ring of steel around it. Only certain people allowed inside it, because we didn't want the whole organization to have access to that data. And then they, as long as it's got good documentation, it's like a catalog of data, and they can go jump in there. You've got all your tools set in there. You've got your Spark, you've got your notebooks, and everything in there. We use Zeppelin to do that. So that's a big investment. And then finally, it's really important to start getting that collaboration. It's not a software engineer versus data scientist. You have to start working together, because software engineers are really good at productionization and scaling. And we've had a lot of problems in the past with deploying code from data scientists, Python into containers and all that. And we had issues in production. So I think you almost want to pair up with a software engineer from the beginning, actually. And that's where the software engineers need to be able to learn the basics and be able to converse with data scientists to make that happen. That's kind of my learnings over the last 5 years in dealing with data science. Cool. That's thanks, and open to any hearts. What do we do? Everyone's gone. I've just been talking to no one. Oh yeah, cool. Yeah, no worries. Move on. Yeah, cool. Yeah.
Brilliant. That's what I like to hear.
Was that what? Just Alex?
I believe we're back now. Wow, just a whole host of technical issues going on tonight. Thank you very much for that, John. That was really insightful. I like those charts on the pyramids as well. Hoping get a share on those slides perhaps a little bit later after the session. That would be cool. So we're going to save Q&A for the end, and go over those towards the end. Danny, have we got Danny with us? Oh no.
Hello?
Hello.
Okay.
I can hear you.
Perfect.
Brilliant,
You were
brilliant,
breaking up. I was like, oh my God, it happens every time.
Oh no. Okay, so yeah, if you wouldn't mind sharing your screen with me, and then I can pop you on this one here.
I think if I'm breaking up, let me know and I'll swap laptops. Just let me.
Okay. Oh, you are a little bit broken.
Can you hear me now?
I can hear you. Yeah.
Sorry, just this web app, it consumes a lot of
Yeah, that's become quite apparent. Sorry about that.
And and live coding now. I think I'm stressing my luck. Just give me a few seconds to share my screen.
Okay, brilliant.
Why doesn't it let me share my screen now?
Well, I might fire off one of my questions to John if while we're getting set up here. John, if you can hear me. Oh.
Yeah, I'm in the house.
Awesome. Well, one of the questions I was going to ask that came along the route is you showed the pyramid with the different roles at different points along the way.
Yes.
It seems and talk about waterfall approaches to the delivery. I was just wondering obviously, like you said at the end, you want to get software engineers and data scientists together. So kind of how do you kind of manage both requiring data scientists at the end, but also kind of requiring them at the outset to kind of collaborate with the software
Well,
engineers?
no.
Is that somewhere where you'd look to go for contractors or?
Oh, so no, so no, I was actually, maybe I didn't communicate that very well.
You may have. I might
Yeah.
have just been in the
No,
middle
I
of
was
something.
basically
Sorry.
saying traditionally people get the feeling that data science can only happen in a waterfall fashion, but I was suggesting that you can deliver it in an agile manner, and that's where I showed the data value pyramid, where you can and here it is, you can deliver value at each level here. So you don't have to wait till you get to the top. You can start delivering business value, with the charts, the reports, and then you go up to the predictions. So it's still not straightforward. You might need solutions that are based on machine learning might go over quite a few sprints, but you don't want to you want to try and get in the situation where, like, a lot of this kind of research you want to do it over 6 months. But yeah, no, I was saying you want them collaborating early. But
Right. Okay.
if you do hire data scientists early, they might not be doing any machine learning for a while, because they're going to
Well, yeah.
on the basics of collecting data. That's really good, actually, because if they get in early, they get really to understand the data quite well. So they'll find stories in it. But yeah.
Okay. Okay. Cool.
We've lost it.
Well, it looks like we've lost Danny now completely. She might be trying another laptop, I think she mentioned.
Okay, yeah, cool. Let's have a look on YouTube.
On the YouTubes? I haven't got it up at the moment. It seems to tax my machine more than this does.
Any questions on the YouTubes?
Oh,
but yeah, it's super hard to bring these two cultures together, though, and within the agile framework, it's super hard. So that's where you really have to go writing the problem statement, really working with everyone on that problem statement. What outcomes? How could you incrementally deliver? You need to put a lot of love into that area, because you will get to, you want to avoid, it's just classic risks, with waterfall projects. You're spending months and months working on something, and then you get to try it out and it doesn't deliver what you want. But it can be painful. And, I've also learned a lot from some of the data scientists I've learned everything from them. And it took me a long while to realize, because they were saying, I wasn't presented with these kind of pyramids, but we had, the first set of data scientists we hired in New York, young guys and girls, are super motivated, and they just jumped straight in. But we had more experienced data scientists. They're saying they don't want to be messing around in the top of the pyramid when it was so messy down the bottom. He's saying, look, we just really need to start from the beginning and have a proper data flow, proper data structure, and abstractions through it. So we actually in the end, we were clashing quite a bit, because I was misinterpreting them as not wanting to ship quickly, being a bit lazy, so to speak. But no, so we split two data scientists out of our Scrum team, and then we just let them kind of put them in research mode and just checked in once every week, and they revisited our full data stack. Yeah. And it was for a few months. So, but it's super hard, super hard. Yeah. And yeah.
Yeah, that makes sense. That makes sense.
Yeah.
There has been a few questions come through on YouTube now. I was spotting them, but now I can't find them. If anyone's got it up to hand.
How many data engineers compared to data science do you need? Is there a ratio? I actually think, well, more. I've got an opinion on data scientists. I actually think you only need one. You'll only need one for ages. If you've got a good data scientist, they're almost more of a consultant to a certain degree. And as a PO, they're awesome. They're almost like a PO, actually. They can really help you. One of the guys I work with, Juan, he really enables you to see the product from a data point of view and see things that you've never seen before. So, and then, it can, So, but data engineers, again, ratio, I'd say you probably need more. It depends on the size of your, data and if it's real-time data or anything like that. But I would say, you need fewer data scientists if they're a good one. They do a mixture of consulting, and if you've got a data scientist who's not really involved in production, they produce more. So a lot of the way we'd hand over from software engineer to data science to software engineer, and hopefully we see Danny as an example. They would hand over Jupyter Notebook to the software, and it's like a prototype. And then, there'd be loads of toing and froing, particularly on the maths, and finding, an equivalent library in Java, and the model wouldn't produce the same result, but we'd hand over Jupyter Notebook. But yeah, data engineers are important as well. But I don't think you need many. Yeah.
So many varied roles that need to mesh together. Can be quite difficult, I imagine, to kind of get everyone on the same page, understanding everyone's individual kind of commitments to the work and what they've got to actually produce.
Got one more question here from Jay.
Oh yeah.
Also, do you allow them to pick up their own tools or have a standard set? So we try to standardize it, but generally for data scientists, we don't want to limit them. So we created what we call a data science lab, and enable them to use tools that they're comfortable with, just so that they can really deliver value. I mean, it's so it was a bit more freestyle, and also they could go and get data where they wanted, but I started to control that a little bit, because if they're building a prototype and they'll say, well, you got that data from that source, and I actually don't think that's productionized, so in order to, I'd rather you take it from this API because you just found it in an S3 bucket somewhere. But generally we allow, wanted the data scientists to use what tools. Data engineers is a no-go. They're building infrastructure. That's like, that's standardization. Yeah.
That has to fit the template.
Yeah.
Yeah.
Oh, it's the clap going on.
Sorry?
Clap.
Oh, yes.
Yes, back for the carers.
Yeah, we've found ourselves at the wrong time for these events.
It's all my family out there. Right.
Busy street. I think we've lost Danny. She's trying to join.
I'm here. Hi.
I keep oddly seeing my own face where Danny should be. That's really creepy.
Hi, can you
Danny?
see me?
Are you with us?
Yes, I've been trying to connect with my other laptop, but it says the link has been expired by the host.
Oh no.
So I was making attempts. So live coding, and let me see if I can share my screen without having this exploding. Share screen. Share screen. Untitled Jupyter Notebook. I was advised. Can you see my screen now?
I can't yet. No.
It says Jupyter Untitled.
It's not coming through into the green room yet.
I can see it down the bottom there.
It says Jupyter Untitled, and it has a localhost 880 notebooks, documents, happiness. Can you see that?
I can't. No. Have you streamed it? Ah, there it is. I've got it.
Let me
Excellent.
see what you see. Yes, that's exactly what what you're expected to see. Excellent. So
Right, bear with me. Bear with me. Let me just get it added in, and we'll get you streaming out to YouTube in a moment.
and this is the data scientist dance.
It looks very familiar. It looks like the web developer dance that I'm all too familiar with as well.
Oh, yeah, we teach it. It's the only dance, and then it's like the dad dance that you do to the corporate party.
All right, give us a sec. We're just repositioning it. Oh, there we go. Excellent. Right, perfect. Okay, I think we're ready. Let me push the button, and we'll.
We're not live. Are we live? Can you hear me? Hello? Okay. Should I keep saying stuff just to make sure that you can hear me? Okay. Let me see. What should I talk to you about? Okay. Hi, internet. Yeah. So, I'm going to demonstrate what I do for sometimes during the day. Today I didn't do that. Today I pushed code to production, which was the first time I've done this at work because I changed jobs. It's been 5 months since I changed jobs, and it didn't go very well because my code had some mistakes, some omissions, but I have a very good team leader who is very patient. So I'm not going to show you what I did on that today, but I'm going to show you what I do before that. In my previous job, before I joined GridEdge, the startup that I'm working at, I used to work as a geospatial data scientist, and my area of expertise is outlier detection. So I can see things that I can write patterns that identify things that go wrong. And this is what I've done in my current job, and this became, and now we are trying to develop it further and give it to the wide world. So I'm going to, as John said before, I'm going to do the reports, report clear and record data the other way around. So I have downloaded some data sets from Kaggle. The data sets are about global happiness, because everything was coronavirus these days on data, and I don't want to analyze data that I'm unfamiliar with and I haven't had proper training. It's a very weird territory to tread at the moment for me. So I'm going to talk about happiness, and the data science, the data sets that I'm using are used to inform the World Happiness Report, and it is a landmark survey of the state of global happiness. So this is a Jupyter notebook. It is a web interaction it is a web application which allows me to write code, to write text, to do visualization. It's implementing LaTeX equations as well. So I can do a lot of things, and I can export it as a PDF, as a report to my client. So it is CRISP DM compliant. Let me name this notebook as happiness and NorDev con name. So let me give it a name first. So markdown, hashtag. Can you see me typing at all, or I'm just... And you can see only this notebook? Okay, exploratory analysis. Yeah, because I have a kernel open, and I wanted to show you which environment I am in. But I'm in the base environment, so you work in different environments in Python. And because I'm doing an exploratory analysis, I'm not working on a specific virtual environment, which is a virtual environment is tailored to the specific application that I want to do with my data. If I want to do supervised learning, I have one virtual environment. If I want to do unsupervised learning, I have a different environment that includes different libraries. But when I'm doing basic stuff like that, I have a base environment. So that's what I wanted to say now. Import pandas as PD. Pandas is a library written in Python, and it's used for statistical data analysis. So let's start with one data frame first, equals pd.read CSV, and let's read the 2019.csv. I'm going to show you three different types of data visualization. I can't possibly comment which is best and which is worst. I like them all equally. So when Python comes and you have to do a notebook, please there are like Matplotlib, Bokeh, Seaborn, name 5 libraries. So I have the data. And typing the method get, I'm looking at the first 5 lines. Now you're counting from first, the happiest country, the score is 9.79, and you can see that Finland, Denmark, Norway, Iceland, Netherlands, etc. If I type df.tail, I can see who is in the bottom of the list, df 2019. And this is why you don't live code, because you show your inability to type or to remember data frames. So you can see here the bottom of the list. Now, what if I want to see where United Kingdom is? df20, just out of curiosity, dot look. I mean, in 2019, we're pretty happy here, right? I guess, I think. df 2019, and it's called country or region. I can't see the comments at the moment, but I usually like to ask for guesses, like where do you think we are, what's going on, and what have I done? I've mistyped United Kingdom. There we are. So United Kingdom was 15, number 15. And this way you can query your dataset to find a specific country, okay? I will move forwards. Now what I want to see is to have some information of my data set to see if these are numbers and not strings, because sometimes the numbers are typed as strings and I really don't know if they are what they are until it's too late. That is, I've written all my functions and methods and try to parse them. So let's see what we have in there. 2019. We are looking at which also think that it's convenient. Sometimes we have strings that are descriptive values, and there are a lot of methods to deal with this. Either you convert them to 0, 1 values, you convert the comment to a list, and it adds a 0 if it's not, and a 1 if it's correct, or you can have a 1 to 5 categorization, which I don't recommend, because what I found out with data is that sometimes it can be interpreted as a quality index, and it causes problems. It's not only for distinction, if that makes sense. So please note that I haven't seen this data set before. I checked it like 30 minutes ago. So I don't know what is going on, and it might be a bad idea. What I see in this data is that I don't really understand the units of the numbers I see here. And I have a pet peeve with units. I always want to know what is this counted as. And what I usually do in my notebooks, I write what I want to say to the client really early on, so that I will communicate it early to them and mitigate the risk, or make them aware that your data set is missing stuff, or this is not what it's supposed to be. How would you like me to proceed? What do you want me to do? And it's good to communicate clearly with your client at the beginning. And I'd like to say lower their expectations, but in reality is give them a good representation of your problem and what is happening. So let me write here, ask the client to provide info about the units of the data set. As you can see here, I'm using Markdown, so it's easier to see it when I skim through, so it's red. And maybe I will come and visit this cell and write more comments, like ask the client to approve extra costs or whatever, and then delete it. It looks nice, this data set, but I still can't draw any preliminary conclusions. So I want to see which parameter here correlates highly to what. If I say that I have a high GDP, does it mean that I have a high generosity as well? I want to see the correlations. To do that, I need to that is as SNS. It is good practice not to keep this everywhere, but to put it at the very beginning with the rest of the libraries. So let me run this cell again, and ever max plot lib dot plot.
Right, I'm going to jump over to all four of us. Okay, I think we've lost Danny there. I think it will, to be honest. The happiness index in my office has dropped substantially. Yeah, it has from my end as well. Oh, I just heard myself. Somebody's got on stream. You're right. Okay, we'll give her a couple of minutes, maybe. Yeah. I think it's commonly resound that we're going to be using Zoom next time. I figured we'd try this though, because no, we can still stream to YouTube from Zoom. I just figured it was a little bit more accessible. You could watch this in your front room, can't you? Whereas you totally can't watch the Zoom in your front room. Yeah, same built into Zoom, I think. And you can do scheduled stuff with the RTMPs and stuff. So mm, yeah, same really. Exposure, but no actually use of it. Um, yeah, yeah. You miss Yeah, missing missing out on opportunities left, right, and center. I mean, the closest I've got to data science is maybe a Google Analytics report, but um, yeah, that's about it for me. But it's something I'm certainly massively interested in. And machine learning in general is fascinating. Yeah, quite. Yep. I've just been made aware that at the moment, I think the only person that can be heard is me. Which is the worst perspective on this entire conversation you could possibly have. I do apologize to everyone out there. Yeah, I think it's a good idea, to be honest. My massive apologies to John and Danny. Thank you for being willing subjects of the NorDev experiment that was streaming to YouTube. Um, Yeah, I don't think we'll be back on YouTube anytime soon. It has been an experience and a use of an immense amount of CPU power. Yeah, globally spiked the power usage. Right. Yeah. Cool. So yeah, thank you. Sorry again to everybody. We'll be back in a week with another live coding session on Zoom. You'll be pleased to hear, and we'll be back in a month with some Jamstack. Potentially. We were going to do that on YouTube, but I think that'll be going out on Zoom. So yeah, thank you everyone. Sorry for all the dramas, and yeah, everyone give us a wave at least.